A to the power 1 over n is the nth root of A. 49 to the 1/2 is the square root of 49, which is 7. Ooh, there's a misprint here. A to the 1/3, not 1/2, gives you the cube root of 64, which is 4. So this is 1/3, not 1/2. 64 to the 1/2 times 64 to the 1/3 is the square root of 64 plus the cube root of 64, so 8 times 4, 32. Or we can add the exponents. We get 1/2 plus 1/3, which is what? 5 over 6. The 6th root is 2, and 2 to the 5th power is 5. We could have done it that way. And maybe I should have done it that way to show you that we can add fractional exponents. Example 9. Oh, that's an interesting example. A young prince, a child about 5 years of age, became heir to a throne a long time ago. He asked his mentor to invent a unique, clever, entertaining game. If the prince was satisfied with the game, he would grant the mentor any wish. The mentor decided to teach the prince a lesson. He came up with a game of chess which involved a board with 64 squares. He asked the prince for a grain of wheat on the first square, double that or 2 grains on the second square, double that or 4 grains on the third, and so on. Keep doubling until all 64 squares are filled. How many grains of wheat should be on the 64th square? And you can use a calculator. At least that's one story for the invention of the game of chess. A good story. So square 1, 2 to the 0, square 2 to the 1, square 3, 1 exponent 1 less than 3, square 64, exponent 1 less than 3. So 2 to the 63 is about this ridiculous number here, which is approximately 9.2 times 10 to the 18. So move the decimal point 18 places to the right. This number of grains exceeded the amount of wheat available in the whole world at that time, and maybe even today. The young prince could not keep his promise of granting the mentor his wish.